Hello everyone. This lesson we're going to do the delta Y calculation for three-phase transformer. Delta Y connection is very common in three-phase power distribution, where your high voltage side is delta, but the low voltage side is a Y connection. So this is a special, very common one, and they require special attention to this one. First, we're going to talk about this three-phase transformer connection. If you still remember, when we're talking about three-phase connection, for delta Y transformer, there's some kind of special requirement. For the phasor diagram and the connection diagram also, they have some special requirement. It differs from any other Y, delta, and the Y delta. For delta Y, you can see on the low voltage side, the Y side, all the X1 is connected to the neutral conductor. That's as our phasor diagram indicate. Then for phase A transformer, X2 is actually connected on line B, and B phase X2 connect on line C, and the C phase X2 connect on line A. So we mentioned for delta Y transformer, X2 connect onto the same line as H2 for the same phase transformer. So you can see a phase A transformer, H2 connect on B, so X2 connect on B. Phase B, H2 connect on C, X2 connect on C, and the C phase X2 connect on A line, and H2 connect on A line. So delta Y transformer is very special, and it's very common. So when you do those transformer connections, you have to pay special attention. One more point I'm going to point out: secondary is a Y, so the neutral have to be grounded. Now let's look at the calculations. Supply 3-phase 3-wire, 12 kVA. Low 3-phase 4-wire, 277 to 480 volts. Each transformer is rated for 167.5 kVA. Primary side, line voltage 12 kV, phase voltage 12 kV because it's a delta connection. Secondary side, line voltage 480 volts, phase voltage 277 volts. It's Y connected. Maximum kVA of the load, for balanced load, I have a 3 transformer, so 3 times each transformer kVA rating, give me 502.5 kVA. For this maximum kVA, I can calculate maximum current on primary and the secondary side. Primary line current, we've been seeing this formula for a very long time. So line current, 24.18 amps. Phase current, 13.96 amps. Delta connection, line current gonna be √3 higher than the phase current. Secondary side, line current, 604.4 amps. Phase current, 604.4 amps. Y connection, phase current, line current, phase current, they are all the same. Let's look at the transformer ratio. Each transformer's ratio, 12 kV, 277, give me 43.3 to 1 ratio. Phase voltage ratio is always the same as transformer ratio. Line voltage ratio this time, 12 kV over 480 volts, give me 25 to 1 ratio. So the line voltage ratio becomes 25 to 1. It's different than the phase voltage ratio, different than the transformer ratio this time. If you remember, for the last few lessons, only YY, delta transformer, they will have the same ratio across all 3. For delta Y delta, the line voltage ratio will be different than the phase voltage ratio and the transformer ratio. Now, let's calculate if 200 kVA load is put on this transformer on the secondary. We're using the total kVA, do the calculation for primary side. The line current gonna be 9.62 amps. The phase current gonna be 5.56 amps. It's delta connected primary side, so these two current gonna be different, but the two voltage will be the same. Secondary side, line current 240.6 amps, phase current 240.6 amps. Because secondary is a Y connected, Y connection, phase current, line current are the same. So this is the example of delta Y three-phase transformer connection and the calculation. If you have any question, connect us online or send us emails.